We need to solve the differential equation given by x squared minus y squared times dx minus 2xy dy equals to 0. Let us begin by rewriting our given differential equation as 2xy dy equals to x squared minus y squared dx. Or simply put, dy over dx is equals to x squared minus y squared divided by 2xy. This is a homogeneous differential equation. The reason being, if we consider this function f of x comma y equals to x squared minus y squared divided by 2xy, we will make the substitution x with lambda x and y with lambda y. Then we will obtain back the original function x comma y. When this criterion is fulfilled, we say that our given function is a homogeneous function. And since the function is homogeneous, so this is going to be a homogeneous differential equation. So that means we can rewrite the function as, if we divide both numerator and the denominator with x squared, we have 1 minus y squared over x squared divided by 2 times y over x. Why we have divided with x squared? We could have done that with y squared instead. The reason being, since we have dy over dx, this means that y is the dependent variable and x is the independent variable. So we will consider y over x equals to a new variable v, and we will substitute this into a differential equation. Also, y over x equals to v is simply y equals to v times x. And when you take the derivative on both sides with respect to x, we will get dy over dx equals to the derivative of v times x. So this will have to use the product rule, and this will be v plus x times dv over dx. Now in place of dy over dx, we will use v plus x dv over dx, and we will substitute y over x with v. So let's do that. This differential equation now becomes v plus x times dv over dx equals to 1 minus v squared divided by 2v. What we have done, we have replaced y over x with the new variable v. So x times dv over dx. Now we will take the v from the left hand side to the right hand side and divide it by 2v minus v. We'll combine these two terms, so this will give us 2v. We have 1 minus v squared minus 2v squared. So we have x times dv over dx, or simply put, x dv over dx is equals to 1 minus 3v squared over 2v. Why did we do the substitution at the first place? Because if we go back to our original differential equation, this cannot be converted to this variable separable form unless we make the substitution y over x equals to v, which is seen in this situation here. That means our differential equation in the variable separable form will be 2v over 1 minus 3v squared times dv equals to dx over x. So this is in the variable separable form. Now we can integrate both sides. The integration of the integral on the left hand side can be performed by using the method of substitution. So if we take 1 minus 3v squared equals to, let's say, some variable t, differentiating both sides with respect to v, this is going to give us 6v dv is equals to dt. Dividing both sides with negative 3, we will have 2v dv equals to negative 1 over 3 dt. That means we can replace the numerator 2v dv with negative 1/3 dt, and in the denominator we have 1 minus 3v squared, which will be replaced with t, and this simply becomes negative 1/3 of natural log of t. That means the integral is negative 1/3 times natural log of t equals to integration of dx over x, so that will be natural log of x plus the constant of integration. But since we have considered everything to be in terms of log, we will consider our constant of integration in terms of log. So we'll write it as natural log of c. Using the property of logarithm, we have natural log of t raised to the power of negative 1/3 equals to natural log of x times c. I can get rid of the logarithm from both sides, so this will give us t raised to the power of negative 1/3 equals to x times c. So here t is 1 minus 3v squared. We need to replace it, where 1 minus 3v squared raised to the power of negative 1/3 equals to x times c. If we take the cube on both sides, we have 1 minus 3v squared raised to the power of negative 1 equals to x times c whole cube, or simply 1 minus 3v squared equals to 1 over x times c cubed. And we also need to substitute the value of v with y over x. So we have 1 minus 3 times v squared will be replaced with y squared over x squared equals to 1 divided by x cubed times c cubed. Multiplying throughout by x cubed, so we have x cubed minus 3xy squared equals to 1 over c cubed. Now c is a constant, the 1 over c cubed is also going to be a constant, so we can replace this with a new constant a, where a is equals to 1 over c cubed. Therefore, we can say x cubed minus 3xy squared equals to a. So this is the required solution to a given differential equation.